China just turned on a dam that produces more electricity than 10 nuclear power plants running simultaneously. They launched a space station that will be the only crewed outpost in orbit after the International Space Station retires. They deployed a fully autonomous mine, 0 human workers underground, operating 24 hours a day inside a mountain in Inner Mongolia. They sent a crewed submersible to the deepest point of the ocean, 11 kilometers down, where the pressure would crush a standard submarine like a paper cup. They are manufacturing humanoid robots at a price that has cut the American competition off at the knees. And right now, as you watch this, they just broke ground on a dam so large it will generate more power than anything ever built in human history. China isn't building the future, China is running it. And the rest of the world is only now starting to pay attention. Let's start underground, because this one changes everything about how we think about energy. Meet the Baihatan Dam, the second most powerful hydroelectric dam ever built on Earth, sitting on the Jinsha River between Sichuan and Yunnan provinces. Its 16 turbines generate 16,000 megawatts of electricity. That's enough power to supply the entire city of London continuously from one dam on one river. Each turbine is the size of a 20-story building. The underground powerhouse cavern carved inside the mountain to house them is 438 meters long, 88 meters wide, and 88 meters high, large enough to fit 3 St. Paul's cathedrals stacked on top of each other, inside a mountain, with 16 turbines spinning. China built it in 8 years. Since coming fully online in 2022, Baihatan has generated enough electricity to avoid burning 19 million tons of coal every year. That's the equivalent of taking 8 million cars off the road, permanently, every single year, from one dam. And Baihatan is not even the most ambitious dam China is currently building. In July 2025, China broke ground on the Yarlung Sangpo project, a $168 billion hydropower system in Tibet that will generate 60,000 megawatts when complete, nearly 3 times the power of Baihatan, more than any structure ever built in human history. China isn't satisfied with building the second most powerful dam on Earth. It started building the most powerful one too. But wait, because China isn't just building on Earth. Look up. The Tiangong space station is fully operational. 3 modules, a permanent rotating crew of 3 astronauts, solar arrays spanning 50 meters, and here's the timing that matters. The International Space Station is scheduled to be deorbited and fall into the ocean in 2030. When it does, China's Tiangong will be the only crewed space station in orbit around Earth. The only one. Every country that wants access to a crewed space station will have to ask China. Tiangong is not just a research outpost. Chinese scientists are conducting experiments in microgravity crystal growth, advanced materials production, and pharmaceutical development that physically cannot be done on Earth. Certain protein crystals, semiconductor structures, and biological compounds only form correctly in 0 gravity. The products being developed inside Tiangong today will be manufactured commercially and sold globally in the 2030s. China is already building the factory of the future. It just happens to be 400 kilometers above the ground. And while China's astronauts orbit above, its engineers are going the other direction, deep. The Fenduja submersible dove to 10,909 meters, the full depth of the Mariana Trench, the deepest point on Earth. The pressure at that depth is 1,000 times the pressure at the surface. It would crush a standard submarine in seconds. The Fenduzi's reinforced titanium hull withstood it. A crew of 3 sat inside for hours at the bottom of the ocean, collecting rock samples, water samples, and biological specimens, and mapping terrain no human being had ever seen. China has now completed more crewed dives to full ocean depth than any other country in history, and they're not doing it for the view. The deep ocean floor contains polymetallic nodules, fist-sized rocks packed with manganese, nickel, cobalt, and copper, the exact raw materials inside every electric vehicle battery, every wind turbine, and every smartphone on Earth. China is systematically mapping where they are, how many exist, and quietly building the international legal case for deep-sea mining rights under UN maritime law. The batteries that power the next generation of clean energy technology are sitting on the ocean floor. China intends to be the country that mines them. In Inner Mongolia, China built the world's first fully autonomous coal mine. No workers underground? Not one. Autonomous tunnel boring machines carve through rock. Robotic coal cutters extract the material. Self-driving conveyor systems carry it to the surface. AI systems manage the entire operation from a control room staffed by a small team of engineers watching screens above ground. The mine runs 24 hours a day, 365 days a year, in conditions that would kill a human worker. Toxic gas pockets, extreme cold, unstable ceiling sections, total darkness. The robots don't care. The mine produces 10 million tons of coal per year. 0 workers at risk underground, 0 shift changes, 0 sick days. China plans to convert 60% of its mines to fully autonomous operation by 2030. At that point, one of the world's most dangerous industries stops being dangerous. And here's the number in robotics that stops everyone cold. Unitree's G1 humanoid robot costs $16,000. The Boston Dynamics Atlas, the American equivalent, costs over $150,000. China just undercut the global robotics market by 90%. Not 10%, 90%. At $16,000, humanoid robots stop being a luxury for well-funded research labs and start becoming affordable for factories, warehouses, logistics centers, and eventually ordinary businesses. China is currently producing thousands of units per year and scaling production aggressively. By 2027, analysts project China will manufacture more humanoid robots annually than the rest of the world combined. The economics of human labor and manufacturing are about to change permanently. And China will be the country selling the machines that change them. But here's what ties all of this together. It's not just the individual projects. It's the speed. Baihatan Dam, built in 8 years. The Channel Tunnel, 50 kilometers, 2 countries. Some of the world's best engineering firms took 6 years. China built a dam with a cavern the size of 3 stacked cathedrals inside a mountain in 8. The Tiangong space station went from approval to fully operational crewed facility in under a decade. The autonomous mine was designed, built, and put into production in a time frame most Western countries couldn't complete an environmental impact assessment. And the Yarlung Tsangpo project, the largest infrastructure project in human history, broke ground in 2025 with a target operational date of 2035. 10 years for the most powerful energy structure ever built. So step back and look at everything together. A dam generating enough electricity to power London off one river. The only crewed space station in orbit after 2030. Areas where China's already building a commercial manufacturing operation in 0 gravity. A crewed submersible at the bottom of the Mariana Trench mapping the raw materials of the future economy. A fully autonomous underground mine producing 10 million tons per year with 0 workers at risk. Humanoid robots at $16,000, undercutting American competitors by 90%. And a new $168 billion dam that will generate more power than anything ever built in history, currently under construction in Tibet. China isn't competing in these fields, it's leading them. And the gap isn't closing. In most of these areas, it's widening, year by year, project by project, record by record. Because here is the reality most people in the West are not confronting directly. Every one of these projects was built with Chinese engineering, Chinese capital, and Chinese speed. No waiting for international partnerships, no foreign technology transfers, no decade-long public consultations. China identified a problem, decided to solve it, and built the solution faster than any other country would have, at a scale no other country currently matches. The gap between China and second place in most of these fields is not a few years. In some areas, it is a decade, and China is not slowing down. Drop a comment. Which of China's projects do you think the rest of the world should be paying the most attention to right now?